Welcome. Let us discuss some important questions from continuity and differentiability, which are of HOTS type, higher order thinking skill questions. Okay. These questions will be extremely useful for students appearing for board examinations. Now consider this question. Discuss the differentiability of f of x equals x into modulus x at x equals 0. To answer this question, first of all, you remember modulus x. We know that modulus x is minus x for negative numbers for x less than 0, and that's equal to x for x greater than or equal to 0. So our question reduces to f of x equals x modulus x will be for negative numbers it is x into minus x, that is minus x square, and this is x into x equal to x square for x greater than or equal to 0. Now we try to find the derivative at x equals 0. You have the basic definition: f dash of 0 equals limit x tending to 0 f of x minus f of 0 by x minus 0. To get the limit, we have to find the left hand derivative at x equals 0, which is given by limit x tending to 0 minus f of x minus f of 0 by x minus 0. Now 0 minus means negative numbers. For negative numbers, f of x is minus x square. That's given minus 0 by x minus 0. So this will be limit x tending to 0 minus x, which is equal to 0. The right hand derivative at x equals 0 equals limit x tending to 0 plus, as usual, f of x minus f of 0 by x minus 0. Here, for positive numbers, we have defined f of x to be x square. So it is x square minus 0 by x minus 0. That is limit x tending to 0. On simplification, we get limit x tending to 0 x, which is equal to 0. Here the left hand derivative equal to the right hand derivative. So the derivative exists at x equals 0. So we get that f of x is differentiable at x equals 0. That's all. Now coming to the next question. Show that the function f of x equals x sine 1 by x for x not equal to 0, 0 comma x equals 0 is continuous but not differentiable at x equals 0. We are show that it is continuous but it is not differentiable at x equals 0. To discuss continuity, first of all you find limit x tending to 0 f of x. Here limit x tending to 0 f of x is limit x tending to 0 x into sine 1 by x. Now when you give the limit separately, you give x equals 0. So it will be 0 sine 1 by x. We know that sine theta will always lie between minus 1 and plus 1. So as x approaches 0, sine theta, sine 1 by x, sine theta will be a number between minus 1 and plus 1. As x approaches 0, 1 by x will be a large number. As sine becomes sine of that angle. When that angle becomes very large, sine theta will be lying between minus 1 and plus 1. So it oscillates between minus 1 and plus 1. That we know. When sine theta comes in the first quadrant, we get values from 0 to 1. In the second quadrant also, we get values from 0 to 1, as sine theta is positive in the second quadrant. But when it comes to the third quadrant, it will be negative. In all these cases, sin theta will be a number between -1 and +1. So 0 into a finite number, answer will be 0. Also one that f of 0 equals 0. So limit extending to 0 f of x equals f of 0. This shows that f is continuous at x equals 0. Now find the derivative. F dash of 0 equals limit extending to 0 f of x minus f of 0 by x minus 0. F of x as usually is x into sin 1 by x divided by x, which is equal to limit extending to 0 sin 1 by x. Again, sin 1 by x is a number lying between -1 and +1. As x approaches 0, 1 by x will be very large. So the number will not be a constant number, finite number, but it oscillates between -1 and +1. So the limit does not exist, that is f of x is not differentiable at x equals 0.
An institution for innovative teaching, medical and engineering entrance coaching, CPTCA entrance, crash course, private tuitions, brain development program for children from 3 to 14 years, Integral, Galaxy Building, Kattanam. 94475 66683 94471
Now coming to question number 3. The function, show that the function f of x equals modulus x plus 1 plus modulus x minus 1 is not differentiable at x equals 1. Here we redefine f of x from the property of modulus x, that is modulus x will be minus x for x less than 0. So for x less than minus 1, modulus x plus 1 will be a negative number. Modulus x minus 1 will be a negative number. So we write it as minus of x plus 1 minus the other one is also negative, minus of x minus 1. And this will be minus 2x. And this happens for x less than minus 1. When x lies between minus 1 and plus 1, here modulus x plus 1 will be positive and modulus x minus 1 will be negative. So we write minus of x plus 1. Now, if x greater than or equal to 1, both x plus 1 and x minus 1 will be positive for values greater than or equal to 1. So we write that. So in all these cases, we have to split the modulus function into different categories. So we are getting the first part minus 2x for x less than minus 1, 2 for minus 1 less than or equal to x less than 1, and 2x for x greater than or equal to 1. Now after redefining f of x, we try to find f dash of 1. F dash of 1 is limit extending to 1, f of x minus f of 1 by x minus 1. Now left hand derivative at x equals 1 is limit extending to 1 minus f of x minus f of 1 by x minus 1. Now for values greater than less than 1, we have f of x equals 2. The definition is given there. So 2 minus 2 by x minus 1, 2 minus 2 is 0 by x minus 1. Answer will be 0. Now here we find the right hand derivative at x equals 1, which is limit extending to 1 plus. For values greater than 1, f of x will be 2x. That's definition is given. So it is 2x minus 2 by x minus 1, which is 2 into x minus 1 by x minus 1. Cancelling this x minus 1, we get it as 2. So left hand derivative not equal to right hand derivative. So f of x is not differentiable at x equals 1. Similarly, we can check the differentiability at x equals 1. Okay.